Welcome back to Real GMAT Problems, Episode 9. Doing real GMAT problems is one of the most data-backed ways to improve your score. So let's go through a few examples together and help you accelerate your progress. It's been almost 5 years since Episode 8, so it's probably about time to revive this series, and I hope you'll agree that it's valuable to use real case studies of past exam problems in order to improve. We're going to walk through 3 examples of actual past GMAT questions together. They're from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. But I know many of you won't be in that situation, and that's fine. I've set up this episode for any situation that you might be in. What I'll do is I'll give you a chance to work through the solution on your own if you want to, and then I'll discuss my thoughts on the problem and my recommendations for what to take away from each one. What I recommend is pausing after I read through each problem and, at the very least, thinking about how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but see how far you can get with the mental solution. And that alone is a great workout for your brain. If you're on the go and have access to pen and paper, like if you're on a plane, for example, or a train, that's ideal. Try to make some progress on the problem before we review and focus on good scratch work habits. You want what you write down to be clear enough that someone else can tell how you thought through the problem just by looking at what you write. If writing isn't practical right now because you're driving, running, at the gym, or something like that, that's fine. Just do your best to visualize what you would write down and how that would look. For most of us, that's going to be 100 times more productive than just trying to do all the computations mentally. Here we go. This is problem number 26 from the quantitative section. The problem reads, if the quotient a divided by b is positive, which of the following must be true? I'll read that again. If the quotient a divided by b is positive, which of the following must be true? Answer choice A. A is greater than 0. Answer choice B. B is greater than 0. Answer choice C. A times B is greater than 0. Answer choice D. A minus B is greater than 0. And answer choice E. A plus B is greater than 0. Take a moment if you like. I'd recommend pausing the episode because I'm just going to dive into the sequence so there isn't just 2 minutes of dead air here. So initial thoughts here is I would definitely recommend rewriting it as an inequality so that you have A over B is greater than 0. That's a good way to signify that the quotient A over B is positive. There's a couple reasons to rewrite it that way, so let's talk about that. This A over B greater than 0 is a fairly common pattern on the exam, actually. So it's worth mentioning that they'll often use this framework when they want to tell you that two numbers have the same sign. If A over B is positive, that means either A and B are both positive or A and B are both negative. It's definitely a sneaky way of providing that information, and that's a good example of why they call it a quote-unquote reasoning test. It's called quantitative reasoning, not just quantitative knowledge. So it's not just about knowing the math, it's about being able to see problems from a variety of angles. And this is a simple example of that, but it's still indicative of the style that they use. And as you approach more and more complex questions, I think that you'll just find that that same type of thinking in that same situation just scales up. So the good news here is you can develop pattern recognition through practice. So when this type of situation shows up again, you're much more likely to think, oh, that's telling me that A and B have the same sign, either both positive or both negative. But if you haven't seen that before, don't hit the panic button. You'll see it again, and you'll be much more prepared next time. This is part of the point of preparing for the exam. Now, if you notice that A over B is positive or A over B greater than 0 means that they both have the same sign, that does make analyzing the answers much easier, I think. So if A and B just have to have the same sign and you think about option A is greater than zero, that doesn't necessarily have to be true. Like A could be less than zero. And when a question asks you which of the following must be true, it's asking you which of the following is always true or which of the following has to be true. And it doesn't have to be true that A is greater than zero. We could have A be -1 and we could have B be -1, and the quotient -1 divided by -1 would be positive. So A does not have to be bigger than zero. B has the same logic. Option B says B is greater than zero. That doesn't have to be true. They could both be less than zero. So we can knock out A and B like that. Now C, option C, A times B is greater than zero. That's a different story. And that definitely has to be true. If A and B are both positive, the product A times B is definitely going to be positive. If A and B are both negative, then the product A times B is going to be positive as well. And you could theoretically stop right there if you're confident enough, and C is the correct answer. Now, if we wanted to analyze option D and E, you would note that A minus B does not have to be greater than zero. In fact, that's not true if B is larger than A. Like all it said is A over B is positive. It doesn't mean that A over B has to be greater than 1. So like A could be 3 and B could be like 70. And 3 over 70 would still be positive. But if you look at option D, 3 minus 70, not positive. So that doesn't have to be true. It could be false. E doesn't have to be true either. E is only true if they're both positive. But if A and B are both negative, which we talked about how they could be, then A plus B is definitely not going to be bigger than zero. So if you're concerned about D and E, that's the complete analysis of the answer choices. So there's definitely a lot of speed advantages to knowing the theory here. And again, this is a simple example of this, but I think you'll find that the basic concepts scale well. Even though those speed advantages exist and it's worth knowing the theory, it's not a bad situation, this type of question, to just plug in some numbers, especially if you're not getting traction with the theoretical approach, or if you're the type of person who just struggles with the theoretical approach. I found there's a certain type of student who like you can memorize all the theory, but it just doesn't like click for some reason. And if that's you, then I think you should favor the plugging in number approach in this kind of situation. And if that's not you and you like the theoretical approach, that's great too. They both have like pluses and minuses. You can think about it that way. So it's probably going to take a little bit more time to plug in numbers, but it is often the safer approach, especially if you don't resonate with the theoretical way of thinking on these types of questions. So quick example, let's make A equal to and B equal to. Let's just make sure that that's allowed by the problem. 2 divided by 2 is 1. That's greater than 0. So this is allowed based on the constraints. The constraint is just A over B is positive. Now I'm going to just eliminate any options that don't work. The question is asking which of them has to be true 100% of the time. So if I can just find one situation where one of the answers doesn't work, then I've proven that it is not always true and I can eliminate that option. So when A equals 2 and B equals 2, the only one I can eliminate is option D. But that's something. I've got some traction on the question. And if I'm not feeling the theoretical approach, or I'm exhausted, or I'm worried I'm going to make a mistake, this is a great backup option. Like I said, it could take more time, but it's often the safer route to making sure you don't miss a question you know how to do or could theoretically do. More on that later. So at this point, I'll try some negative numbers. In fact, a great tip is anytime you see greater than 0 or less than 0 or the words positive or negative in a GMAT quant problem, that problem is almost always testing the concept of positives versus negatives. So if you're going to plug in numbers, that's a great clue that you can use to your advantage. You're probably going to want to plug in some positives and you're probably going to want to plug in some negatives and potentially even combinations of positives and negatives if it's allowed. Now, this question does not allow that. It's got to be either both positive or both negative, which is great news for us. It limits the number of cases we need to test. But it's just something to look out for in the future. And again, it's part of that pattern recognition I was talking about that makes future questions you see easier to approach. So let's try A is -2 and B is -2. -2 divided by -2 is 1. That's still greater than 0, so that's allowed. Now option A, option B, and option E all disappear, and I'm left with C. So it's a great example of the value of plugging in numbers in a systematic way when you're noticing that you have greater than, less than 0, and testing positives and negatives. In my opinion, there's no like right or wrong between those two approaches. And in a perfect world, I think you're comfortable with both. And then you've practiced enough that you intuitively select the right approach for you, depending on the type of question you're seeing. But I do want to say that can take quite a bit of practice to get to that level. So for now, it's totally okay if you have a path that you tend to favor personally, just whichever one you personally resonate with. And I would recommend just working on defaulting to that favored path, but keeping the other method as a backup when needed. I think that's how you'll find the most resilience in your approach to the quant section. And there's definitely problems that are written expressly to fool one type of approach or the other type of approach. So it really, really pays to be able to do problems more than one way. It's not critical, but I would say if you're going for any score above the 90th, 93rd percentile, that's when it really, really starts to pay dividends. I mean, it definitely pays dividends lower than that. If you're just aiming for like a 605 or a 615, which are great scores still, but just not like 90th percentile, it still really, really pays. But I think if you're really gunning for those super top scores, that's when you really want to challenge yourself to be able to do problems more than one way. So those are my complete thoughts there. Reach out to us anytime if you have questions about any of this advice or any of these questions. We're at the GMAT strategy on current social channels. You can also reach us via email. Our email address is contact, CONTACT, at thegmatstrategy.com. All right, problem 27 in the 11th edition of the official guide, I think is a little too easy, and it's also very graphical, so it's probably not going to translate super well here. So I'm going to skip to problem 28. Problem 28 reads, how many minutes does it take John to type Y words if he types at the rate of X words per minute? Y and X are letter variables here. How many minutes does it take John to type Y words if he types at a rate of X words per minute? Option A, X divided by Y. Option B, Y divided by X. Option C, X times Y. Option D, 60 times X divided by Y. Option E, Y divided by 60 times X. Take a moment and give this some thought. Now, some of you might be thinking this sounds a little too easy, and we are technically in the easy level of the book right here. But I think it is surprisingly easy and surprisingly common to make mistakes on this type of question. This is something that I've seen a lot of people struggle with. They know the math, they've got a good approach, but their execution is not good enough. So some advice here, work on your visual organization for all word problems. It really pays to have great visual organization across the entire quant section for sure, without a doubt. You'll hear me talk a lot about that. But for word problems in particular, I think that's the place where people have the most resistance to doing good visual organization because word problems tend to be more time intensive and they tend to be more time intensive up front in the problem. Like this is not a super long example, but you can imagine an example that's 5 times as long as this. And maybe halfway through the problem, you might be sweating already thinking like, man, this is taking a long time. I haven't even finished reading the problem and the kind of the panic can start to set in. I just want you to know that's totally natural. Pretty much everybody feels time pressure to some extent on the exam. Most of us to a massive extent. Like we feel way more time pressure than we want to. There's ways around that. In fact, if you haven't been to our website and checked out our video on how to reach your dream GMAT score in half the normal time, I'll talk you through some approaches you can use to mitigate that time pressure. But even with a great time mitigation strategy, time pressure mitigation strategy, you'll probably still feel it, maybe even a lot. So again, it's totally normal to feel that way. You just don't want those feelings to govern your actions. That's the key. It's totally fine to feel X, Y, or Z. In fact, most of us would like, it's probably fair to say that we can't really control our feelings, our like gut instinctual reactions to things, but we can control what we focus our attention on. So even though you're having those feelings, you can still focus your attention on good visual organization. And I think what you'll find is when you really invest in that good visual organization, you'll actually end up finishing problems faster. You'll feel slower while you're doing the problem. But if you look at the clock time, you'll probably end up finishing them faster. Feel free to test me on that with your own approach and skills. But just make sure you're looking at a broad enough data set to actually make good inferences. Don't have it be like 10 questions where you didn't focus on it and 10 questions where you did. Let's go for at least like 30 questions in each bucket. Okay, so most word problems are going to be an organizational challenge rather than a mathematical challenge. For sure, you can see word problems with tough math, but it's really not the majority, which I personally find really interesting. So let's talk about how to get better at visually organizing these kinds of questions beyond just the like mindset shift I was just talking about. Tactically, I think less is more, and I think rows and columns work super, super well. So when you're thinking about how to organize word problems, I really recommend just thinking rows and columns. So if you don't know what I mean when I say rows and columns, think about like a spreadsheet, but just you're not drawing all the lines between the cells, if that makes sense. So let me give you an example on this problem. Here, we've got a question that involves rates and work. The most common expression you're going to see in these questions is rate times time equals work. If I can type 10 pages in an hour and I type for 3 hours, I'm going to type 30 pages. That's my rate times my time equals my work. So we can make some rows and columns out of that. Across the top row, I personally just like to write the formula rate times time equals work. And then as I go down, I can create a new row for each instance of that formula in the problem. It's really common to have more than one instance of that formula in rates questions. In this question, there's only one, and that's partly because we're in the easy section of the exam, of the book. But as we get into harder and harder questions, you'll notice there's like 2, 3, 4, 5 instances of that formula, and the rows and columns really come in handy. Now, interestingly, personally, I think the rows and columns come in handy even when there's just one instance of this. And I'll back that up with a little bit of data in a second. So under the rate column, if you will, so across my top row, I've got rate times time equals work. Now I've got like, I'm treating that R at the top as like the rate column. I'll write X, words per minute. And I will write the units. I'll write the variable X and then I'll write W over M for words per minute. More on that in a second. Under the work column on the far right, I'll write Y, and then right next to the variable Y, I'll write words. I will literally write the word words. And I think you'll find a lot of value in these word problems and rates questions in particular of tracking your units very carefully. The variables don't mean much to us usually if we're like more real world thinkers. If you have like a lot of quantitative experience, then you might be so comfortable with variables this is irrelevant, but just keep an eye on it. It's my advice. But for the majority of us taking this exam, we're not working with variables in this kind of way on a regular enough basis that we're going to automatically be like caching the logic, for lack of a better expression, like already having the logic ready to go when it comes to the relationship between X and Y. And writing the units is going to really help you organize the math. Again, word problems are generally an organizational challenge rather than a mathematical challenge. So writing it this way, visually depicting it this way, helps me see that I'm missing the time variable. That's convenient because the question is asking me for that. It's asking me how many minutes. So I've got a couple options here. I can solve for that missing piece in the chart. That's acceptable. Or I can make a variable for the unknown. So I'm going to make a variable because I think it translates to an audio-based lesson better. But you can feel free to solve for that variable using X and Y instead if you prefer. It's totally up to you. I'm going to make a variable called t minutes for the time, and then I have a nice little equation here all of a sudden. I'm going to write t minutes right under t in r times t equals w across the top. So right below that, I've got x words per minute times t minutes equals y words. And those units are just a nice triple check that I've got the logic of the problem set up properly. I haven't like reversed anything. I'm not multiplying where I'm supposed to be dividing. I'm not dividing where I'm supposed to be adding. This is like crazy, crazy common how often this stuff happens, especially when you put people under time pressure and the stakes are really high. And that's part of the skill most of us are trying to develop through this process is becoming better decision makers and better resource allocators under pressure when the stakes are high, which is what I would imagine most great leaders feel like most of the time in big businesses. Now, all I have to do here is solve for t. That's what the question's asking me for. So if I divide both sides of the equation by x, I'll get t equals y over x, which is option B. If you're not so good with your algebra skills, then we will link a lesson on algebra skills. We've got a nice GMAT math basics lesson on algebra if you're a little rusty there, if you're just getting started listening to this right now. So feel free to listen to that and come back if you like, or you can proceed through the rest of this lesson and then head to that one. I think you'll find that GMAT Math Basics series really helpful, especially if you're like starting from scratch and it's maybe been a decade or two since you've done some math by hand. So our answer here is option B, y divided by x. That's the correct answer. So it's interesting to note that a good percentage of people end up selecting C. It's like more than 5% end up selecting C. And option C, if you forgot, is x times y. So think about that. The correct answer is y divided by x, but a lot of people pick y times x or x times y. So what does that suggest about what people are doing in this problem or how they're thinking? It definitely suggests we've got a problem with people either not staying organized, not setting up their units properly, or rushing because the problem looks simple, or they're like too focused on the time pressure. And some amount of focus on time pressure is healthy. You do want to keep track of time. You don't want to just like wing it in, I mean, 99.9% of cases. I mean, maybe some people are fast enough where they can wing it. This definitely wasn't me. Certainly not my students. But if you're rushing, if you're not setting up your units properly, or you don't have good visual organization, it's just terrifyingly easy to pick those wrong answers because you just got a little turned around with the logic. And I think that's why a lot of people are picking C here. So what I recommend is counteracting those kinds of misses because we definitely want 0% risk that you'll miss something like this, or as close to 0% as we can guess. So here are a couple principles you can use. Number one, create the habit of labeling things clearly when you're transcribing what's given in word problems. I already recommended the rows and columns thing, and that's what I've seen the largest number of people have success with. But if you have a better system, that's totally fine. As long as you have a system that leads to zero misses due to organizational problems, you're good. I recommend the rows and columns thing, but really anything that gets you that 0% error rate is great. Principle number two, I strongly recommend building the habit of writing units from the beginning. I already was harping on this. I just want to repeat it because I think it's that valuable. And looking back on my studies, I wish I was a lot harder on myself with this from the beginning. I ended up creating a lot of bad habits in the first few months of my study, and then I had to counteract those. And maybe that's just the kind of learner I am, like a little stubborn, or maybe more than a little. But let's be generous here, since it's just me. Um, even if you don't need to do that to get questions right. So even if you don't need to write units from the beginning to get questions right, I'd still recommend developing the habit. What's a little generosity amongst friends here? Definitely pays massive dividends down the line in my experience. And writing units is a good way to stay more organized in general. It helps you avoid missing questions you know how to do, even if it wasn't crucial to you getting the problem right. And it also makes a lot of questions easier to solve because you can see which numbers go where, and it's less likely you're going to get confused. And I find that a lot of people try to save time in like the wrong way, if that makes sense, or like they try to save time in a counterproductive way by like rushing. But I think a good principle to abide by here is haste makes waste. And I think that little rhyme is like nice, kind of sticks in the mind. And it's a good mantra to have. Like usually the faster we try to push ourselves, the more risk we end up incurring. But if you just build these good habits from the beginning, then you can go fast at writing the units, you can go fast at making columns, you can go fast at organizing things well. And that's how you get fast and good. You start good and slow, and then you start to apply the pressure once you feel like those good habits are locked in. And there's a million analogies I could make to other skills where that tracks. So that's my advice. Principle number three, take your time at the beginning of your studies to build good habits. This is very related to what I was just saying, but it's so important and it caused me so much pain and suffering, and I see it cause so many other people so much pain and suffering that I just want to try to like super overemphasize it for you right now. And just hopefully it'll help you out as much as it would have helped me out. So just Avoid that temptation to focus on speed too early. Speed will come with repetition, no matter what you do, actually. But if you build speed doing the wrong thing, now you're just accelerating your progress toward a score you're not going to be happy with. That's what happened to me. My score just kept going down every time I took the test, even though I was putting tons of hours in between those practice tests. So take the time to build a great foundation. And when you eventually get fast, you'll be fast and good, like I was just talking about, which is what you want on test day. Quick final point on this question. Just like the previous one, it's a great time to plug in some numbers, actually. This is especially useful if you're not super comfortable with variables or algebra for any reason. All of the above tips still apply, but you can use a very logical solution with numbers. So I'll just walk you through an example real quick. Let's say I pick X is 20 words per minute and Y is 60 words. I'm going to set everything up exactly the same, except instead of writing X in my chart, I'm going to write 20. And instead of Y in my chart, I'm going to write 60. And then just somewhere else on the page, I'm going to write X equals 60. Excuse me. My apologies. I'm going to write X equals 20 words per minute, and then I'm going to write Y equals 60 words somewhere else on the page. And then I'm going to look at my chart and say, oh, it'll take 3 minutes to type that. If I'm typing 20 words a minute and I type for 3 minutes, I'm going to get 60 words. So like that can help if you're experiencing friction with the algebra and the variable piece for any reason. Again, you'd still want to practice that as a backup approach, but it's totally acceptable to use plugging in numbers as a default approach on these questions. If you're not sure how to plug in numbers well, we've got a whole lesson on that titled How to Plug in Numbers on Problem Solving Questions from back in 2020, actually, and that'll be linked below. Now I'm just going to replace X with 20, and I'm going to replace Y with 60 in every answer choice. And the one that yields 3 minutes, same as what I just solved for, that's going to be the correct answer. And you'll notice that if you did that, option B is the only option that yields 3. So it's a nice little trick to have up your sleeve. Again, if you're not familiar with that tactic of plugging in numbers and you want some help structuring that well, highly recommend that episode from about 5 years back now. So to summarize, plug in numbers if you're not comfortable with algebra, and do your best to develop good habits from the start of your studies, especially on simple, easy, lower level questions. That's a great place to start developing these good habits. If you've been studying for a while and you're like, oh, shoot, I haven't been having good habits and it's costing me a lot of new but missed type questions. Best time to plant a tree is 10 years ago. Second best time today. So highly recommend that you start that. If you don't do easy questions well, it's just super unlikely that you're going to do hard questions well. Could happen. Certainly there's exceptions to like all the platitudes and truisms here with GMAT. Like some of you are just so talented. It doesn't matter what you do. You just can't help yourself. You're going to get an incredible score no matter what. But that's definitely not the majority of us. So those are my thoughts there. Again, reach out anytime if you have questions. Let's do one last problem together. This is problem 29. This problem reads square root symbol over 16 times 20 plus 8 times 32. Okay, so I'm going to read that again. Underneath a square root symbol, the entirety of what I'm about to read is covered by the square root symbol. It's 16 times 20 plus 8 times 32. Okay, so I've got 16 times 20 plus 8 times 32, and that whole thing under the square root symbol. Option A is 4 root 20. 4 times the square root of 20. That's option A. Option B is 24. Option C is 25. Option D is 4 times the square root of 20 plus 8 times the square root of 2. And option E is 32, just the number 32. Take a moment here and see what kind of progress you can make. There's a few viable solutions to this one, and honestly, the brute force approach is not that bad. And by brute force, I mean just like running all the computations. So to brute force this question, excuse me, just do all the math from the inside out. And as long as you follow PEMDAS, things should work out well. If you're not sure what PEMDAS means, or if it's been a minute since you thought about PEMDAS, we've got an episode on that linked below as well. I'm not going to walk you through all the long computation here, but if you want help improving with long multiplication, long addition, and long division, we've got specific episodes on all those skills linked below as well. So feel free to do those and then circle back to this problem if you want. While there are strategies to get around doing long computation in general, it is super, super valuable to be able to brute force things if it comes to that. So highly recommend developing those skills. With that being said, let's assume that you could compute 16 times 20 either in your head or on paper to get 320. And that you could also do the same with 8 times 32 and get 256. Let's further assume that you could add those together and get 576. And so now we've got the square root of 576, and that's our problem. In general, I recommend memorizing your perfect squares up to 20, but if you want to memorize them up to 30, that can be useful, and this problem makes that somewhat obvious. But actually, the odds of seeing the square of 25 or the square of 26 are super low. This question is an exception to that general rule, though, because 576 is just 24 squared. So there's your answer. It's B. Now, if you had memorized that approach becomes a lot easier, and you can simply select B at that point. But for a lot of you, the brute force approach is going to stall out there, and you might be kind of stuck, like, shoot, I don't know the square root of 576, and that's super understandable. In fact, even memorizing it, some people aren't going to notice it. So if you don't want to memorize your perfect squares up to 30, or you're just worried that you're going to forget them, then prime factoring is actually something that can really help when you have big numbers under square roots. So let's talk about prime factoring a bit. It might have been a while since you prime factored some numbers. Again, totally okay. You can relearn that or learn it for the first time fairly quickly. In fact, we've got a whole episode where I do go into that. If you want some help with that, that'll be linked below as well. And just to kind of shortcut that for you, the basics of prime factoring are you just keep dividing by prime numbers until you can't get any more prime results. So if you're like, wait, what's a prime number again? Then you might want to hit some of those episodes linked below first and then circle back to this one. So let's demonstrate this. I can divide 576 by 2. 2 is the smallest and the only even prime, which is definitely worth memorizing for sure because the GMAT loves that because it doesn't really seem like it should be prime, but 2 is a prime number, smallest and only even prime on the GMAT. 1 is not prime on the GMAT, everybody. So I do 576 divided by 2, and I get 288. Again, totally fine if you need to do some long division there. You can divide 288 by 2 again to get 144. You can divide by 2 again to get 72. You can divide by 2 again to get 36. Divide by 2 again to get 18. Divide by 2 again to get 9. And then you can divide 9 by 3 to get 3. And that's the complete prime factorization of that number. After that, if you kept dividing, you would just get 1 as a result, and 1 is not considered prime, and that's prime factoring. We just go until we can't divide and get any more primes as a result. That's the end of prime factoring. So most people are going to create like a tree diagram so they can count up all the factors after performing the operations, and I definitely recommend that when you're prime factoring. If you just do a quick web search, you can figure out exactly what I'm talking about there. Just like visualize prime factoring, that'll probably net a good result. So if you count up all the 2's, you'll notice there's 6 of them. And then if you count up the 3's, you'll notice there's 2. So what this means is if you multiply 2 by itself 6 times and then multiply that result by 3 2 times, you'll get 576, which is kind of cool. Each integer has a completely unique prime factorization. Prime factorization of an integer is kind of like its DNA. No other integer shares that prime factorization. Just side note. It's kind of fun. So at this point, we've got 2 to the 6th power times 3 to the 2nd power under the square root symbol. And in this situation, it's probably best to think of the square root as an exponent of 1/2. That's what I personally like to do. And there's much more on that in the exponents lesson linked below if you want. If you don't have your basic exponents and roots material together yet and you're just getting started, highly recommend listening to those episodes first. Come back to this when you're ready. Now, if you write the exponent as to the 1/2 power, that can help you see that you're going to cut each exponent in half. So the result is going to be 2 to the 3rd times 3 to the 1st. 2 to the 3rd is just 8. 3 to the 1st is 3, perhaps obviously. 8 times 3 is 24. So while it's obviously great if you have 24 squared memorized, it's not essential. So think about what will play to your strengths and make that your note to yourself for this problem. Should you be the prime factor type person where you're ready to do that? Or should you be the memorize in advance type person? No right or wrong, just whatever resonates with you personally. Okay, now there is one final approach to this question, like I mentioned, which is just factoring out perfect squares. This is going to be a little bit more advanced because it requires a bit of like X-ray vision into the numbers involved. And if you're already good at this, you probably figured that out right away, and that was probably your default approach to the problem, which is fine. But if you're not already good at spotting this, it's definitely something you can work on and get better at seeing over time, like I mentioned, the whole pattern recognition thing. So the concept that we're talking about here is taking the square root of an addition. That's what's happening in this problem. And that's annoying because I can't distribute roots, excuse me, over addition, but I can distribute roots over multiplication. And that's why factoring is so helpful. It turns things that used to be addition or subtraction into multiplication when I factor out a common term. If you don't know what factoring means, that's there for you in the Math Basics series. In the case of square roots, the ideal thing to factor out is a perfect square because square rooting perfect squares is usually the easiest thing to square root because I'm going to get an integer result. Now you might notice that there is a perfect square in the first term, 16 times 20. 16 is a perfect square. So what we can do is we can look for 16 in the second term. Now we don't get that right away, but you might notice that 8 times 2 is 16. So we can ask if there's a 2 in 32 that we could borrow from the 8 times 32 piece to make it 16 times whatever. And that's part of the reason working on prime factoring is helpful. It can help you with that like X-ray vision I was talking about. So it's a good stepping stone. It'll help you visualize the move I'm about to make here, which is rewriting 8 times 32 as 8 times 2 times 16. 8 times 2 times 16 has exactly the same value as 8 times 32. 8 times 2 times 16, I could do the 8 times 2 part, and that would turn into 16 times 16, which means we have a 16, a perfect square, in both terms. So as written now, the problem is square root of 16 times 20, and then I rewrote the second term as plus 16 times 16. So I'm going to factor 16 out of both terms, and under the square root, that's going to give me 16 times in parentheses 20 plus 16. Let's add 20 plus 16, and we're rewarded for this move because now we have the square root of 16 times 36. Remember I said factoring can turn an addition into multiplication? This is great news. So we actually have two perfect squares under the root right now. Now this doesn't always happen, but obviously when it does, that's really nice. So now we just square root each one individually because, again, it's totally fine to distribute roots over multiplication, and we get 4 times 6, which yields, unsurprisingly, 24. So that last solution requires a little bit of insight. Again, you might have had that naturally, or you might develop it over time, or you might just use one of the alternate methods I talked you through, and that's completely fine. What I want you to know is, again, there's no right or wrong way to take the exam. You want to survey all the available approaches to a problem, ideally, and then pick the one that resonates most with you personally. That I've found is the fastest way to building your personal, quote unquote, best approach to the exam. Now, if you're the kind of person who doesn't want to think about that and you want someone to just tell you the quote unquote best way, then the best way is always the safest way. Meaning that is the way that is least likely to cause you to make a mistake. A lot of people think that the best way is the fastest way, but the biggest score killer in the quant section is not actually lack of speed. It's missing questions that you know how to do. And if you haven't discovered that yet, it's likely that's the case. But I could be wrong in your specific case. So maybe speed is the thing you really need help with. And we've got a whole episode devoted to how you can build speed down below. Now, I hope you got at least one valuable note or something valuable reinforced by that lesson, ideally more. Again, message us anytime, and please just let us know how things are going and if you like this direction that we're taking with our content here. Definitely value your feedback highly. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content. And check out our video on how to reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you soon.